Hey guys, so today we're going to be talking about ESRT page 6 or Earth Science Reference Table page 6. And in page 6 of your reference table, you'll find this chart, the relationship of transported particle size to water velocity. What this chart is showing you is the speed or velocity of a stream, how fast it's going. And depending on how fast the stream is going in the x axis, the particle diameter or how big of a particle of sediment can that river or stream carry depending on its velocity or speed. Okay, so let's take a closer look. Let's look at number 5 on your worksheet. It asks, what is the stream velocity needed for zero point 0.2 centimeters of pebbles? So to do this question, first let's take a look at our entire chart, right? Our x-axis is showing the stream velocity in centimeters per second. It's showing how fast the river is going, okay? Our y-axis is showing the particle diameter in centimeters, or in other words, how big of a particle can that river or stream carry. This side is showing the type of particle that river is carrying, our stream is carrying based on its velocity. For instance, if my river is going 100 centimeters per second, if I go up and stop at the black line that's created, I see that this would be my particle diameter around 2 centimeters, and that 2 centimeters is the size of pebbles. Another example would be if my stream velocity is 50 centimeters per second, then, or actually 500 centimeters per second, that river would be carrying a boulder right here or cobbles, right? And also notice the, um, what are these? Indents are not equal, right? They're kind of spaced out differently. It's fine. Just look at each boxes for finding out the, how each number is changing with each increment. For instance, if this is 0.01, then this must be 0.02, 0.03, 0.04, 0.05, and so on. But look at this box right here. If this is zero point 0.1, then this is 0.2, 0.3, 0.4, 0.5, and so on. Look at this box. If this is 1, then this must be 2, 3, 4, 5. Look at this box. If this is 10, then this must be 20, 30, 40, 50. And finally, this box, if this is 100, this must be 200, 300, 400, 500, and so on. Okay, so look at each box, each section to figure out how each increment is going up or down. So, anyway, number 5, what is the stream velocity needed for zero point 0.2 centimeters of pebbles? Go ahead and pause this video, try this, and then unpause to check your answer. So the correct answer is 10 centimeters per second. I'm given the particle diameter of zero point 0.2 centimeters of pebbles. Here's zero point 0.2 centimeters, and I know these are pebbles because it matches up with pebbles right here. And if I go sideways, I stop at the black line, I go down, I see that my stream velocity that the river needs to carry that particle would be 10 centimeters per second. Go ahead and try question number 6. Pause this video. So, what particle diameter would be carried with a stream velocity of 1 centimeters per second? The correct answer is 0.02 centimeters or sand. So if I'm given 1 centimeters per second of stream velocity and I want to find the particle diameter, all I do is start from 1 centimeter per second in the stream velocity or x-axis. I go up, I stop at the black line, I go left, and I see that my particle diameter with that velocity would be 0.02 centimeters. That's the size of particle that the river can carry with that velocity or speed. Finally, try number 7. Pause this video. What is the largest particle size that a stream can transport at a velocity of 5 centimeters per second? Now, the correct answer is actually sand, so C. So if I'm given 5 centimeters per second, I start in the x-axis, 5 centimeters per second. I go up to the black line, and I go to the right and see sand is the type of particle that the stream can carry with this velocity. So go ahead and open your note packet and let's write some notes down. So when a stream is flowing, we need to figure out the size of particles it's carrying. You need to go on your reference table, page 6. Okay. So the thing is, when a river carries sediments, those sediments start to go through something called abrasion. So abrasion is basically when sediments become smooth or rounded as they bounce along the bottom of the stream and hit against each other. So as these sediments are flowing with the river, they're starting to bump against each other, rub against each other, and that causes them to round out and even become smaller over time. So that's why when a rock or sediments get transported by water or a river, they go through abrasion and they become rounder and smaller. So if the sediment started out like this, over time from abrasion or rubbing against other rocks, it will start to smooth out, round out, and become smaller over time. Let's write that down. So as my river flows or stream flows, my particle size gets smaller and my particle shape gets rounder. So, another thing we need to learn about is something called sorting. What does sorting mean? When a particle is sorted, that means the sediments are grouped by the same size and shape. So, this is an example of a well sorted sediment sample. All the sediments are about the same size and shape, same shape. An unsorted group of sediments is when the group is it's a mix of different sizes and shapes of sediments. So this is example of a very poorly sorted sediment sample. We have all different shapes and sizes. So if you have the option of writing this down in your notebook, these definitions, and you'll see this coming up as well. Sorted is when all the sediments are about the same size and shape, are grouped together by size and shape, same size and shape, and unsorted is when the group of sediments are all different sizes and shapes. So why are we talking about this? The thing is, let's go back to when a river enters the ocean. This is a river entering the ocean. This is the ocean, okay? When a river enters the ocean, we already saw that the river starts to slow down and deposit its sediments, right? Now, which type of sediments will get deposited first? The thing is, the river will drop the bigger sediments first, the boulders. And I know boulders are my bigger sediments, is because if I go on my reference table, page 6, I see boulders have the highest particle diameter, and then it will drop smaller and smaller sediments. The reason is because if it holds on to the bigger sediments, it takes a lot of energy. Our river is losing energy when it's entering the ocean, so it's going to start dropping the bigger sediments first and then the smaller sediments. So it will drop the boulders first and then the cobbles, which are around 10 centimeters in diameter, and then the pebbles, which are smaller, and then the sand, which is smaller, and then the silt, which is even smaller, and then clay, which is even smaller, and finally precipitates, which are very, very tiny sediments, super tiny. Okay, and this causes sorting, meaning as the river drops those sediments are starting to being grouped by the same size and shape. So we have a group of boulders here, group of cobbles, group of pebbles, group of sand. So we're starting to group the sediments or sorting the sediments in size and shape. So, when a river or any sort of water starts to deposit sediments, those sediments are deposited in a sorted way, meaning they're very well sorted. They're all about the same size and shape. They're grouped that way. Okay. So, in summary, when a river or a stream starts to deposit its sediments, it starts to deposit them in a sorted manner, meaning it starts to group those sediments in different sizes and shapes, right? So this is a size and shape boulders, and then cobbles are all similar sizes and shapes here. Pebbles are a group, sands group, silt is a group, etc. So rivers and water deposit sediments that are sorted. When a river carries a stream, or a particle, sorry, that particle size will start to get smaller and the particle shape will start to get rounder because of abrasion. And if you go on reference table page 6, you'll find out how big of sediments can a river carry based on its velocity. And that's it for now.